We're finding it increasingly difficult to, first of all, attract talent, let alone attract talent that has any kind of experience. And so what we look to do is find ways of automating certain functions on a machine such that customers can still produce a high quality road at the most cost-effective price. And that's really what we're showcasing here today with our Smart Pave solution.
Want to put some extra horsepower behind your operations? Click the link below to subscribe to Equipment World's daily newsletter for the latest construction equipment news, trends, and reviews.
Really the starting point is what we do is we help our customers by recognizing there's an opportunity to digitalize the road work and the plan of what needs to be done on a typical roadway. So our customers would typically work with a consulting company or a surveying company to scan the existing road surface and create a digital model in a DXF file of what the final road surface needs to be and where the paver is actually going to travel. Once the customer has that model built, they can in their own office validate that the model in fact meets the engineer spec or the DOT spec in length and width, etc., that they are in fact paving in the correct spot. Once they are satisfied that that model is acceptable, the customer then, using John Deere Operations Center, which is John Deere's telematics platform, which these machines are connected on, then uploads that file digitally to the selected machine. Okay? From that point forward, the driver can see and recognize that they've received a new file, can acknowledge that yes, that is in fact the job that needs to be done. From that point forward, the steering is then automated. So the driver up there is truly no longer a driver. What he's doing or she's doing is actually then more focused on material flow management, because the machine is going to simply follow the line that's been defined by the digital model. Okay? Similarly, the individuals that stand here managing the edge of the pavement or the edge of the screed, you no longer need to have an individual here. And what we recommend is a single individual standing at the back simply monitoring that the edge of the screed is in fact complying with the model, which not only has efficiency, but also removes the individual from that very dangerous position that I was talking about before. Okay? So really what we're doing is, again, as I mentioned earlier, automating some of those fairly mundane and in some cases fairly unsafe positions and job sites to a much simpler and much more effective solution that certainly results in more efficient paving and again significant savings in material. Here you see what is oftentimes a typical case where our customers in the paving business are often paving at night because of city restrictions, authority restrictions where they can't shut down a road during the day. And again, when you've got people on a roadway, and especially on a roadway close to traffic, significantly dangerous, and so our ability to then do everything we can to eliminate that using technology is paramount, and that's why we see some benefits there. The other one is time savings. Oftentimes roads and where roads need to be placed and pavement needs to be placed is done manually. So somebody's out there on an existing roadway marking the edge of the pavement. That is now completely eliminated by virtue of the model that dictates where the asphalt's going to be laid. One of the significant opportunities that we see is material savings. Almost every contractor never wants to underpave because the consequences of that, either in penalties or rework, is significant. So almost every contractor puts down a little bit more asphalt than they should, just to be sure. The other thing is the quality of that pavement is almost always never perfect because it relies on a manual person paying attention on the edge of the screed controlling the edge. So as you see in this graphic here, there's oftentimes more asphalt that needs to be laid. And the interesting stat here is, you know, in the United States today, we've got about 4 million miles of road. About 3 million miles of that is covered with either concrete or asphalt. When we look at it, over 90% of that 3 million miles is in fact asphalt. So we've got 2.7 million miles of asphalt in the United States. Now, most folks and engineers will tell you they'd like asphalt to last 10 years. Does it? I don't think so, because it depends on a number of factors: traffic flow, the quality of how it was laid, environmental conditions. But if we just use 10 years as an example, that 2.7 million miles over 10 years equates to 270,000 miles of asphalt-covered road that needs to be either replaced or rehabilitated every single year. And if you can save an inch or two of asphalt on every one of those miles, that results in significant savings for our customers and also for us. At the end of the day, a lot of the road work that's done in this country is really funded by taxpayer dollars. City roads, state roads, federal roads comes out of our pocket as taxpayers. And so our ability as a company to help our customers be more effective and efficient in how they lay asphalt really ultimately pays back to us and everybody that drives on the road, because those tax dollars are being able to be stretched a little further. So this material savings is a big one in our mind because of the accuracy of the paving. And then finally, just some of the benefits that come with automation we think are really beneficial to our customers in the way I mentioned. And obviously the opportunity to take an individual that would be normally standing on the side and repurpose them to another part of the job. They can be helping manage material flow in the front, they can be helping with quality control in the back. So it's really about repurposing jobs in a way that the job gets done most effectively and most cost effectively in a timely manner.
For more videos like this, click the playlist on the screen now.